So the second part of this is really kind of going through the assessment elements. And so in your packet is the director's rule. So you can actually see the language that's in the ordinance for this. And so in association with the Pacific Northwest National Lab, PNNL has developed a curriculum in the last few years on building retuning. And so we're basically leveraging or resourcing that curriculum for this tune-up service provider training. And I'll have this organized by these assessment elements, so you can actually see what the assessment element is. Also, just to let you know, in your packet is, oh, I don't know if I have it here. They've put together, maybe, can you, field walk down training guide. Did we get that in there? Yeah. So PNNL was very kind to go through the assessment, and they actually have some of, as you're doing your walk down in the building, and PNNL uses the word walk down for that, uses that term, is essentially what you're going to be wanting to look for at the different elements. So it's called the field walk down training outline. Do you guys have that? Yeah, okay, good, good. So as we go through this is essentially with the diagnostic tool package. This is another resource for you. So, you know, again, what is the assessment element? What do you need to, what kind of points or what kind of information do you need to look at? What's mandatory? What's voluntary? So PNNL developed this retuning curriculum, and they developed it for two applications: buildings with a building automation system, buildings without a building automation system. So let me ask you, you guys work with these buildings, think about buildings in 20 to 100,000 square feet. What percentage do you think will have a building automation system? Half? Probably more. I think we're probably going to see more buildings with building automation systems than without. But is anybody going to be looking at a building without a building automation system? Stephen, you've got one? So on the smaller building side, you're probably going to have that. So we've kind of taken this curriculum and broke it down into buildings that have building automation systems and buildings that don't have building automation systems, because you may actually have both. So as this curriculum goes through, we have non-BAS, which stands for building automation system, that allows, so more that you're going to use data loggers, for example, to verify, or building automation systems where you could use trending. You may have a building automation system, though, that has very little, if any, trending capability. A lot of the legacy systems, and I'm sure a lot of you have worked with them, don't have much trending. So there still may be room for using some of the data loggers for that. So we're kind of looking for, you know, greater than 50,000 square feet, less than as the city of Seattle. And also the PNNL was able to kind of direct this training. Originally, this training was directed towards operators, not service providers, but we've kind of massaged it a little bit to kind of talk about both. Service providers, what they need to be looking at, operators, where those opportunities are. So we kind of all know that persistence of performance over time, right? If, you know, we tune it up, it's kind of like our car, and over time, energy consumption goes up. There's a lot of examples out there that you can show where performance tends to decline over time. And there's a lot of different reasons for that, whether it's budgeting, putting less money into operations and maintenance, equipment efficiencies declining over time, change in use of the building, changes in settings, overrides. So taking it and off, equipment in the hand because of a problem and leaving it in the hand position. So there's a lot of reasons why this would happen over time. So our goal is to basically, with periodic retuning, is just kind of like your car, is that we're going to, you know, tune every 5 years, tune the building back at least to what its original design intent, or what is good practice. You know, we're not asking you to implement control strategies that are leading edge or whatever. What is current practice? If they don't have reset on their discharge air control, they don't have reset on their discharge air control. That might be an opportunity, but from a tune-up standpoint, you just got to make sure that the sensor in it is being controlled by discharge air. So that's something to think about. These are low cost, no cost. There may be other opportunities for you to explore, but this hopefully over time then we get more persistence savings, just like we would tune up our vehicle to maintain its miles per gallon rating and its efficiency. So obviously continuous retuning or monitored based commissioning provides the most savings, where you're continually monitoring the buildings. But generally in smaller buildings, we don't do that. We don't have real-time. Is anybody working with any buildings that have real-time monitored based commissioning? I know, Stephen, this building has that. This building has SkySpark in there that's being monitored in real time. That's one of the, if you look at one of the options out of the tuning requirement, is to do monitored based commissioning and real-time commissioning. But that's generally the exception rather than the norm, especially for this size building set, the smaller buildings. And so we're going to be looking for that. What's the low cost, no cost stuff that we can do to reduce saving, to increase building performance every 5 years? You know, and so this is, PNNL has done a lot of case study work, and you're going to see some of the results of that in this presentation, where, you know, the building was streaming along here at an EUI between 55 and 60. They did a retuning project, dropped it down 50, about 10% or so, but then over time it crept back up like this. So this is fairly typical. It's kind of like nobody's minding the store, energy performance is going to decline over time. So that's relatively, so that's why the 5-year interval came about, is basically this periodic tune-up. We tune up our vehicles. How often do we tune up our buildings? On the way down, on the way back up. So PNNL did a lot of study work on where were the opportunities in these tunings. And so this was on their small to medium commercial size buildings, and by building type, you know, where are the opportunities? And you'll see that, you know, calibrating faulty sensors was relatively low, but some of the key opportunities, and this is reiterated in the director's rule, shorten HVAC schedules. So basically matching schedule to occupancy, or making sure that the optimal start is working and is in place, was a big opportunity across. And these are percentage of savings. These are not additive, but if you just did this point. Another key for non-building automation systems, so the small to medium, say 50,000 square feet and smaller, were wider deadbands and night setbacks. So increasing the deadband, implementing more of a setback. Setback has always been kind of an issue, and we're going to rely on your judgment depending on the system type. You know, there used to be some basic rules of thumb in light frame construction where you had fairly quick recovery. You could get away with setting back to 55. In mass construction where you had a lot of mass, concrete tilt up, brick, you wouldn't go as far down, maybe 60. But now we're starting to see systems out there like VRF heat pumps where you don't do any setback or very little. And actually they consume less energy because they're running at part load rather than trying to recover after a weekend. So we're going to rely on your judgment if you have those kind of systems, is what's the appropriate setback? Are they using that appropriate setback? Are they employing optimum start? And you don't need a BAS system to employ optimum start. Most programmable thermostats now have intelligent recovery. So they have microprocessor based. So are they programming the thermostat based on occupancy or when they want the HVAC to start? I still find a lot of confusion out there as to what, for operators, to what set their thermostat at. Let the microprocessor decide when to start the system. And there's good savings with that. So optimum start, set points, scheduling tend to be the biggest areas. On the larger buildings, there may be some, we'll talk about some of the other measures. But for the smaller commercial buildings, they tend to be the biggest areas of improvement. On the larger buildings with building automation systems, we still have scheduling. Supply air temperature reset. Are they resetting supply air temperature at all? Maybe they were originally, the original design intent was to reset supply air temperature, but for whatever reason, they weren't able to meet their load. It was a humid day and they needed more dehumidification. Whatever was going on, they overrode the reset. never set it back in place. So do they have the capability for resetting? Static pressure reset for VAV systems, if they're capable of doing that with VFDs. VAV minimum box position. I was in talking to the PNNL folks, I was very interested in this, in that, you know, how they discovered this, what they looked at in large offices. And what they would say is what they would see is they'd see a lot of VAV boxes where the minimum flow was greater than 30%. That's a lot on a VAV box. So that was kind of a red flag. And there's a variety of reasons for that. May have been a change in occupancy, low, if it was a squeeze box, maybe it was dumping from the box, so they increased the minimum air position. So there was a lot of reasons for that, but that was an opportunity that they saw in a lot of cases where maybe it was set at 30%, 35% because it was a conference room initially designed 10 years ago. Now it's being used in an office and could be set at 10% minimum flow. And so this was an area that they saw was a big area of potential savings. Was, did the minimum VAV damper position match make sense on that? Wider dead bands, we talked about that. Optimum start, the same thing. So when you have BAS systems, you're going to have the opportunities are going to be more into the control side and specifically on the reset side, whether it's chilled water reset, boiler water reset, fan pressure reset, or supplier temperature reset. And you can download, for those that want to get into the weeds, you can go to PNNL's website and download this information, this report that they did. 100 buildings, they modeled out these savings that they found in the field. And so if you want to get into the nitty-gritty details of what their findings were. So in a data-driven, so you've got observation-driven and data-driven. Observation-driven, you go out, you look at the rooftop unit, you verify that the economizers work. And the data side, obviously, is using the building automation system to identify and correct. How many are you going to be working with building automation systems when you do your tune-up? So you know in that process, then you can verify, you can trend data, or you can initiate control action and observe the response to verify that. So, you know, it's the front end, so you're going to be, in the PNLs put together that guide, is setting up some of those trend logs to help you in the front end with your assessment. So with a BAS building, you're probably going to go in and figure out, what do I want to trend? What am I trying to assess? And get those trend logs before you complete your assessment. Without a BAS system, you may be figuring out where you're going to deploy loggers to do that. So in terms of the measures, so PNNL did this analysis of 100 buildings, and by far, so you know, where were the savings opportunities in these larger buildings with the BAS systems? Discharge temperature reset. You know, it may have the capability of resetting 5 degrees from 55 to 60 or whatever that is, but for whatever reason, they've abandoned that strategy. And it, you know, there's a variety of reasons of why that is, but verifying whether they have the capability of doing that and are they employing that strategy. Same thing on the static pressure reset. You know, with static pressure set points set too high. Has anybody seen a duct static pressure set point too high or higher than it needs to be? And so is there an opportunity to reduce that? Proper schedule for exhaust fans during warm-up. So during the warm-up cycle, before there's occupancy, you're bringing the building up to temperature. Do the exhaust fans need to be on? Generally not. Now, if there's occupancy and you've got bathroom exhaust and that type of stuff, then you probably do want to run those exhaust fans. But generally in the 4 o'clock in the morning when you're initiating your warm-up cycle, 5 o'clock in the morning, you don't need to run your exhaust fans. So you could, how would you verify whether or not the exhaust fans were running? You could trend it. So if you have a start-stop trend, fan on, fan off, you could trend it. Any other ways? Motor logger on the exhaust fan, so I can find out if the exhaust fan's coming on at 4 o'clock in the morning or 7 o'clock when it's occupied. Any other way? Building static, and that's an interesting thing because I trended static on a building one time, and at 5 o'clock at night, when the 6 o'clock at night when the system went down, it would always go negative all night. It would run negative pressure all night, and then the next day it would come up and pressure. So the exhaust fans weren't shutting down at night. So they were running 24/7, basically. But so through building pressure, trending building pressure, we're able to see that the exhaust fans were running at night. Lack of proper scheduling and lack of schedules for fans. So that's kind of one of the primary assessment elements, is to just verify scheduling of the major equipment and systems. If you look at a lot of these buildings, office buildings especially, they're only occupied about 3,000 hours a year. So for 5,000 hours a year, they're unoccupied. So how much energy can we save when they're unoccupied, which doesn't affect anybody's comfort, extends the life of the equipment. Lack of occupancy-based controls for common areas. We'll talk about that. Chilled water reset, hot water, no hot water temperature reset. Faulty sensors, relatively small percentage, but you do want to, I would say at a minimum, you want to verify the accuracy of your critical sensors, those sensors that initiate control action, like discharge air temperature, outside air temperature, mixed air temperature if you've got a mixed air economizer. Zone temperatures sensors, I wouldn't worry about them. They don't fail that often. CO2, probably check that, especially duct-mounted CO2 in the return air. Check those, but zone thermostats, I don't think it's worth the time. So think about the critical sensors that are initiating system-wide control action. Improper dead bands, heating and cooling set points, no night setbacks. Again, keeping in mind the system types. Lack of automatic lighting controls. Well, that's generally a capital measure. It may make sense. Wow, you have no occupancy sensors in this building, or no lighting controls, or the outside lights are on all night. So there may be, and then hot water pressure differential reset fairly small. But again, we can kind of look at the cream on the top there when we think about where the savings are going to occur. So when we look at the focus areas with BAS, I mentioned scheduling. Discharge air, static pressure control, that's central station air handlers with VAV. So what's that set point? Is it adequate? Is it too high? Is it too low? Economizer. And we all talked about economizer before. We have a lot of economizer hours in our climate. So is the economizer working? What are the set points for the economizer? There's good, if you're and there's a variety of reasons for overriding those set points, but is the economizer functioning? Is it using an appropriate set point? And zone conditioning, which is essentially set points. I'll talk a little bit about this. You may have a wild zone or rogue zone. You may have a data closet on a VAV system that isn't allowing the discharge air to be reset, because that VAV box is 100% open 24. Has anybody seen that before? Right? So you have reset capability, but you have one zone that's driving the entire system. So that may be a recommendation to upsize the VAV box, put in a separate system. That's outside the scope, but that's something that we want to know in your analysis, that we can't do any reset because all the air is being demanded by the one zone. So a recommendation. Heating and cooling plants we'll talk about a little bit later. So that's on the BAS side. On the non-BAS side, on the BAS side, you're looking at a graphic screen and you're getting feedback. I will caution you that a lot of what you see on a graphic screen, Steve knows this, is the commanded value, not the actual value, right? So it's a little bit of trust but verify, at least some of that. On the smaller package rooftop units, no BAS, it's going to be physical observation. You've got 10 package rooftop units, you're required to tune up 10 package rooftop units. And so, it's really going to be through the data logging and the physical observations on what you can identify in those systems. And the approach, this observation-driven approach, you guys have been through this. with your experience and qualifications. Collect information about the building. I'll go over that. Nicole hinted on a little bit of that. I want to clarify, talk a little bit about it. The building walkthrough. In order to do a tune-up, you need to walk the building. We did talk a little bit about virtual audits with some of the interval data that occurs, but this is getting out there and actually physically observing or testing equipment using the building automation system. Once you've identified, and I'll call them deficiencies, but let's call them opportunities. If you find equipment that isn't working, then basically repairing or placing corrective measures in place. So that's in the implementation phase. So we talked earlier about you've got an assessment phase. Does anybody do commissioning work here? So the deficiencies report or listing that. So you've done your assessment, you've identified the deficiencies. Here's what needs to get fixed, whether it's a damper, an actuator, a failed sensor, whatever that is, sequence of operation. Then you've got the implement, which is the actual implementation of that. That could happen within your organization. That may be the owner responsible for that. That may be a third-party contractor, but that's the implementation phase. And then the documentation, the reporting of the measures and calculations is your tune-up report. So here's what we found. And if there's nothing, you didn't make any changes, that's okay. You don't have to find stuff. We're hoping that every building will have some opportunity. I think we all agree that there's probably opportunities in every building. But so the reporting of your finding is through that Excel spreadsheet that Nicole went over earlier. So the data collection, just for review on that, general building information, your credentials, building characteristics, benchmarking. We do want you to verify the benchmarking validation. Just is it the right utility? Did they use the right square footage? Did they include the parking area in the square footage? Is the parking area a space definition as it should be? Do they have a big data center that's skewing all the results? Did they not mention the restaurant on the lower floor that's driving the energy use? One of the issues we have in this building is we're having a hard time getting our EUIs down because there's a medical center next door that has a high energy use intensity, and it's kind of driving the entire building's energy use intensity down or up. And so we're looking for, so if there's any obvious problems that you see in their benchmarking analysis, we need to note that so that can be corrected. So size, age, type of building, O&M manual, sequences of operation, types of equipment, recent repairs, maintenance schedules, construction or changes to the building that will affect if there's construction going on, tenant improvements, what's going on there, building equipment schedules, use of the building, and then meter data. And you'll have most of this from just the benchmarking data that you'll have, and I'll talk about that in a minute. But that's the kind of information that you're going to need. You may, if you're a service contractor, you may have a lot of that information for this building already. On the Energy Star, on the Portfolio Manager, I don't know if anybody's, how many of you are familiar with Portfolio Manager? So one of the features of Portfolio, so you'll have for most of the buildings, let's say they'll be benchmarked and with Portfolio Manager. And so you're going to be able to, you can actually extract this data out of it, download property to Excel. So rather than having to re-input, a lot of this data you're going to be able to export from Excel. So when you're filling out your sheets, you're going to be able to get this data export from this information from Excel. So you don't have to regenerate it, square footages, building use, year built, all that kind of stuff. You can export from the Portfolio Manager report. That'll save you some time. You also need to gather annual water use from the owner, irrigation water use and seasonal water use variations. So just a simple analysis of what's the difference between my December water consumption and my August water consumption. And I would assume that most of that's probably irrigation, if they have irrigation. There may be other reasons for that. There's also some information about monthly energy use patterns. Does it go up in the winter? Does it go down in the summer? Is it flat? Also an estimate of annual heating and cooling energy use. So we're not asking you to do a model of the building and tell me down to the kilowatt hour what you think the cooling energy is or the heating energy. If they have natural gas heat, if gas is the only load, then we know how much they're using for heat. So you can just use a simple billing analysis to do this. So we're not asking for anything more detailed than going, here's my plot of my electricity consumption. I'm going to assume that the increase between April and September is for cooling, for air conditioning. So I'll say this percentage is for cooling. This percentage is base loads, not affected. So we do ask questions about what percentage, a little bit of a disaggregation of the energy use, just for heating and cooling purposes. Don't spend a lot of time on it. Make an estimate of the building analysis. You've got the building information in the portfolio manager. You can export that data, do a quick analysis, done. Same thing on the heating side. If you do have base loads on heating, hot water, gas equipment, another seasonal analysis and do an estimate of heating loads. For the medium-sized buildings, and actually for all the buildings, kind of the emphasis is on the tune-up requirements are the HVAC systems, lighting systems, domestic hot water, water use, and building envelope. And I'll talk about building envelope at the end here. It's a voluntary measure, but we do want you to take a look at it. If there's any obvious deficiencies, like there's big holes, there's broken windows. So it's hard to heat the building in the winter with broken windows, or some other deficiencies that you note, it's worth noting on that. So, kind of some of the basic energy management principles, and you guys have been doing this, so you know this. And PNNL kind of, when they look at these buildings, they look at it this way. If you don't need it, turn it off. So is there an opportunity for turning off equipment, turning off lights, turning off circulation pumps when they're not needed? Slowing fans down. If you don't need it at full power, turn it down. So slow the pump down, slow the fan down, dim the lights, for example, daylighting. Make smart energy decisions when adjusting systems. And, one thing is, you can implement a measure, but sometimes measures affect other measures. You reset this, you go, I'm going to save a bunch of energy and set up a reset schedule for my discharge air, and now all of a sudden you've got a room that's overheating because the air's not cold enough. So we do want to think about kind of, are there areas that dry? Am I going to create a problem? Has anybody created a problem by doing a temperature? Right. Never. Right. That's the only way you learn. I slowed the fan down too much. I slowed the pump down too much, or whatever that is. Or now my chiller is not behaving correctly because I don't have enough flow or I don't have enough load on it. So we just want to think about that. Saving energy without negatively impacting the comfort of the occupants. We can all save a bunch of energy. We'll just set the thermostats at 68 for heating. Right? So we want to keep that in mind that, it said looking at set points, but are they reasonable? Are they in the generally recognizing that one thing I've learned about comfort is people will if you don't provide it, people will take control of it. They'll bring in the space heaters, right? So that's an issue of comfort issues, space heaters, fans, sabotage. Those are all symptoms of comfort. So just some of the kind of the themes that we want to keep in mind as we're going through this. So the information phase, when we're collecting this information on the building, this investigation, we're trying to find operational issues. And again, I always get back to this low cost, no cost things. Looking at these systems, using your judgment, what are the low cost, no cost strategies to reduce energy use, make these systems operate more efficiently? And that's really where the retuning. So we've mentioned a little bit about sampling earlier when there's multiple pieces of similar equipment. The systems mandate requires a minimum 12%, no fewer than 10, and no fewer than 20 on large buildings. So use sampling. So when you're developing your scope of work, fees, costs for doing this work, you're going to want to use sampling. A question has come up with, well, what if I do a sample and I discover that 50% have a deficiency. Is there any requirement that I now have to do another sample and figure that? No. But you need to correct those deficiencies and probably recommend to the building owner, I recommend that we go ahead and test the remaining VAV boxes and see if this is similar. Do another 10, or we keep seeing a pattern. But all you have to do is the minimum sample and correct those deficiencies in the minimum sample size. In your reporting form, there's a few boxes where you just describe your sampling methodology. I had 20 rooftop units. I'm only going to test 10. Or whatever. Or I've got 400 VAV boxes. I'm only going to test 44. Or whatever that is. But mention that. So that's similar equipment. So VAV systems, terminal systems, VRF, VAV boxes, water source heat pumps where you have multiple, the Columbia Tower right there, 2,400 water source heat pumps. You can imagine tuning up 2,400 water source heat pumps. So sampling is allowed. Obviously, when you're walking down the building, and this just makes sense that, use your senses, look, listen, smell, touch, does it make sense what you're seeing? Does it make sense? It's important to observe the building during different modes of operation. We know that our buildings generally, unless you're a 24/7 building, we've got an occupied mode and an unoccupied mode. Has anybody done a night walk down or a night walk through? Right? I've always found something on a night walkthrough that could be turned off, or a deficiency, or something to check on a follow-up. So it's good to observe the building both during its unoccupied and its occupied. Also, figuring out what happens in the transition. What happens when we go from unoccupied to occupied, that warm-up cycle. What's on? Where's my outside air damper position? What are my exhaust fans doing? And then also in that transition from occupied to unoccupied, am I doing optimum start? Am I keeping the HVAC on till midnight for the custodial crew? So looking at both of those transitions. A lot of energy waste occurs during unoccupied periods. For those that if you have interval data on your building, what is the demand of the building? What is the energy consumption when it's unoccupied? Or we've had some holidays come up. We've got a holiday coming up on Monday. Does the building get a holiday? Are the holidays programmed and scheduled into the schedules? That's something that's fairly easy to let slip and people not update their holiday schedule for the next year. And so their building's running full out on Thanksgiving Day, Christmas Day. So when nobody's there. In a perfect world, we'd walk the building in the heating season, in the cooling season. We do have some time frame to get these reports into Nicole that spans those two seasons. But, we're looking at different things. During the heating season, for the most part, our buildings are heating dominated. Here, we use more energy for heating. And so, our infrared camera, our air leakage, boiler water resets, those are the issues. As we transition into the cooling season, now we're looking at economizer, chiller operation, cooling tower operation. So ideally, we would do our observations and our tune-ups in both of those seasons. Log the information, record it, however you want to do it. People have asked, is there some kind of a checklist that I can take out there in the field? The answer is no. We didn't develop a checklist. We're pretty much relying on your experience and expertise in developing the building energy asset score. There's $600 or $1,000 there if you fill this out and complete it and go online. So this is a pretty good checklist to take around. And then also the directors, this training outline. So, having, before you're heading out into the field, having some notion of what type of data you're going to be gathering, and the information will help you be efficient. Tools, I already talked about some tools in the tool library. So we have some tools available, whether it's light meters, and I'll throw some other tools at you when we go through some of the specific elements. Something that I have found pretty handy, which we've actually done a couple walkthroughs, is a digital tape. I don't know if anybody's used a digital measuring instrument like this before. Ceiling heights, windows. When I'm trying to gather the information from Richard, we're trying to figure out the length of the building, the height of the building. It's a $400 tape measure. But it'll go 100 meters, 300 feet. So something, just to get some measurements that you can do if you don't have plans or you don't have a good idea for that. Obviously, camera, photo camera, infrared camera is a good tool to have. So you can check out our library and see what we have available in your toolbox, flashlights, that type of stuff. So this last section here, this next section is I'm just going to go through each element. So let's just get down to brass tacks and talk about the scope. What do I need to tune up on this? And by far and away, the largest scope work is on the HVAC side. That has the biggest potential for savings in the building. And so, and you'll notice on here, there's some references to the different tables. This is right out of the director's rule on there. And then on your reporting for the Excel spreadsheet, we have that. And then we have some different specific HVAC. So what do we need to do here? Scheduling, equipment scheduling. So is the equipment scheduled? Yes, no. Does the schedule match the current occupancy of the building? Yes, no. If it's no, what needs to be changed to get it to match that schedule? Set points. And, these are set points that are just generally accepted principles. If the discharge air temperature set point was 50 degrees, I go, wait a minute here. The generally accepted set point for discharge air in a central station air handler with zone terminals is 55. Why is it set at 50? So that would be a kind of a red flag. If there's reset schedules, chilled water, hot water, discharge air. So are there set points for that? We're not asking you to develop new sequences of operation. I've had people ask me, well, I need the commissioning report, and then I can functionally test per the commissioning report. You don't need that. Is the equipment performing per standard practice for that? If you've got those commissioning reports and you can at least have a baseline to go back and compare your tune-up to, great. But that's not necessary. You don't need an OPR. You don't need sequences. Is optimum start-stop applicable? We'll go through this. Sensor calibration, and I emphasize critical sensors. Don't worry about room temperature sensors, but think about those sensors that initiate control action, system-wide control action. Functional testing, that is important. So for those 10 rooftop units, those 20 VAV air handlers, how do they function? Do the controls function correctly? On a rise in temperature, does the VAV8 damper open? On a drop in temperature, does the VAV damper close? On a drop in temperature, does it stay at minimum position and energize reheat? So just use your judgment in applying those sequences to that piece of equipment. Simultaneous heating and cooling. With a VAV system, that's a system that's designed for simultaneous heating and cooling. So, but if there's obvious situations where you have systems fighting each other, like big box retail, you've got one rooftop unit in cooling and one rooftop unit in heating. There's an opportunity there to either control them. I know a lot of the big retailers now are just averaging the temperature in the store and actually using one average temperature as their input. So is there an opportunity to minimize simultaneous? Or you've got electric heaters and electric air conditioning and there's no deadband and they can run at the same time. Air balance we'll talk about in a little bit, and ventilation. And I mentioned rogue temperature zones. So that's the basic gist if you look at the assessment elements. The final one is maintenance, cleaning, and repair. This is a recommendation. But if you notice that equipment is in ill repair, that it's in need of general maintenance and cleaning, the filters are collapsed into the unit, so the filters need to be changed or whatever, those are recommendations that we want you to make. Oh, where's my channel? Excuse me. My slide advancer working. Nope, locked up on me. Thank you. Okay, so if you don't have a BAS system, equipment scheduling is probably pretty simple, right? It's a programmable thermostat or a time clock, right? So pretty easy to check to see if the thermostat time setting is the same, is correct. Has anybody seen a thermostat with the wrong time setting, right? Daylight savings time, it's on a weekend, whatever's going on. Pretty easy. So, you know, is it set to the right time? Does the schedule meet occupancy? Pretty straightforward stuff. We could trend it too. So here's a trend of space temperature versus time. So, okay, we can see what that schedule is. So that's another way of verifying that. We could also use data logger to trend schedule. These are pretty accurate. They'll tell you what time the system's coming on, what times it's going off. Weekends, this basically will tell us approximate set points. It shows us kind of what our low limits are. So we can verify scheduling through trending. We can verify scheduling through data logging. Here's a situation where there was no setback. So during unoccupied hours, this should setback, so it was just maintaining. This was duct static pressure. So if your fan is running 24/7, the static pressure is going to be fairly constant here. So there's, you know, not just we can verify through duct pressure, we can verify through space temperature, we can verify through fan operation, motor, start, stop. So there's a couple of different ways of verifying scheduling. Or just through trending of the pump status. So is it off or on? And it's on Saturday and Sunday. So we can trend that stuff. So there's fairly easy ways of verifying through trending or through data sensors on what the schedules are. Here's a motor logger placed on let it go for 2 weeks, get a weekend in there. Holiday would be great if it's during a holiday, and find out what it's doing. Optimal start, we just want to make sure, this is a PNNL slide that, you know, for those that aren't familiar with optimal start, often called intelligent recovery, is it learns when, based on past demand, when to start the system. And so often what happens is we'll get a cold day like today, the operator will show up, the building's not at temperature, they'll override the schedule and start the system, hard started at 2 o'clock in the morning. Good, now I can sleep tonight because I know it's going to be warm in the morning. This building, by the way, has struggles on really cold days to the point where they're having to override the setback and run it 24/7 to keep it going, which is okay. That happens, but we want you to make sure you go back once it gets milder, that we get past this cold weather, that we go back to an optimum start. So the potential for savings is basically having the microprocessor determine when to start the HVAC, and then you program the occupancy schedule. So we want to make sure that the programmed occupancy schedule is in there. Set points, we're going to rely on your judgment. Do these set points make sense? You know, zone temperatures, I'm kind of like whatever it takes to maintain comfort. So, you know, changing zone temperatures is pretty personal. And I don't want you creating comfort issues and everything. If they need it to be 75, give it 78. What happens at night? Is there a setback on that? This building is pretty aggressive. It starts off, it defaults to 68 degrees, but allows you the occupants to set it up. So it's kind of like the adaptive comfort model. Discharge air, temperature and pressure. So if you've got multi-zone systems, central station air handlers with multi-zone systems, these are two critical things that will affect air, fan energy and cooling energy on there. Minimum outside air, ventilation. And generally My rule of thumb, I had mentioned this earlier, is 30%. If it's more than 30% outside air, then I mark that down as a red flag. I'll follow up and go, oh, you need to provide all this makeup air for this kitchen hood that we have down in this area, or some other process exhaust. But 30% outside air is a high number for minimum, a day like today. It can be higher than 30% for cooling, but we're using it for cooling, not ventilation. So that's kind of my red flag level when I look at minimum outside air settings. Hot water and chilled water supply temperatures, do they make sense? It's 30 degrees this morning, so I'd expect my boiler water to be 180. When it's 50 degrees outside, it should be 160. So what are we using for water temperatures? Does that make sense? Condenser water temperatures. If they have variable speed pumping, differential pump pressure, does that set point make sense? Economizer changeover. There's some dry bulb economizers right now in the Washington State Energy Code. The changeover temperature is 75. A lot of people don't know that you're required to use economizer until the outside air temperature goes above 75. The problem is that generally you can't meet your load, especially with DX cooling systems. So, does the economizer changeover temperature make sense? What kind of economizer are they using? Dry bulb, enthalpy, differential dry bulb, differential enthalpy? And are the set points correct? Outside air temperature lockouts. Anybody had a boiler enabled when it's 80 degrees outside? Or a chiller enabled when it's 50? Right? So just verifying that the lockouts make sense, that my boiler's locked out when it's above 60, my chiller's locked out when it's below 55, whatever that is, what's appropriate for that to try to minimize that simultaneous heating and cooling. Exhaust and process driven systems, so data rooms, garage exhaust. If you've got a building with underground parking, then you're going to probably have, if it's a newer building, you're going to have some sort of carbon monoxide control of the exhaust, or now under the newer codes, it's dual gas, nitrous dioxide and carbon monoxide. So you can test those and see if those are running correctly. Boiler loop temperature, saving on distribution energy costs. And obviously you're going to need to use your knowledge there. If somebody's running their boiler at 180 degrees and you tell them to drop it to 150 degrees, you better make sure that what kind of boiler they have. So we know from experience that condensing boilers can be reset to much lower temperature than non-condensing boilers. And so you're going to have to use your judgment on what's the appropriate resets for these boiler conditions and what kind of system that they're running on their hot water loop temperature, chilled water loops, differential pressure. So we're looking at you to apply, what makes sense in this application. Use your judgment. Critical sensors, we talked about outside air temperature. That's fairly easy. Does it make sense? Is what's showing on the BAS, if you're controlling based on that, is that what my smartphone says? Discharge air temperature, we can measure that. We can insert a measuring instrument into that. We can trend it and see if the sensor and our measurement makes sense. Hot water loop supply and return temperatures. If you don't have a building automation system, I have contact sensors that you can either adhere to or just use a hose clamp and strap and then put insulation over it so that we can log hot water supply and chilled water temperatures. So we've got various tools out there that we can use to verify whether or not these reset strategies are in place. Functional testing. So for the equipment that you're going to test, at a minimum, you're going to want to functionally test the occupied mode, right? So in the occupied mode, the fan runs continuous at a constant speed. On a call for heating, the gas furnace fires and delivers hot air to the space. On a call for cooling, if the outside air temperature is less than the economizer set point temperature, open the outside air damper. There might be discharge air sensor on that. If it's greater than, the outside air damper should be at minimum position and energize mechanical cooling. So just use your judgment for the sequence of operation for that type of equipment. In the unoccupied mode, what should be the status of the system? What's the fan status? Off. Right, we can see that. We can physically do that. What's the outside air damper position? Closed. Right? Otherwise, it's just a hole in the building. Might as well leave the window open. And then we can also verify through warm up. And you, for those that have done commissioning, you know that how you've kind of put these BAS systems through their paces, right? So you make changes in the set points, you initiate these control actions, and so you can we can observe operations and override systems and make sure that we're doing everything. So adjust the control sequence as appropriate for the facility. You know, if you don't have discharge air reset control, you don't need to implement discharge air reset control. It may be a good opportunity on a multi-zone system to do it, but that's a capital improvement. That's a controls project. And so we're just trying to get whatever they got existing there to operate as efficiently as it can. Simultaneous heating and cooling, you know, the boiler and chiller being enabled at the same time, that's always one. I received this photograph from an engineer a while back on, this is a VAV system, which is actually designed to be heating and cooling. And it's something at the code level, we've been trying to figure out how to deal with VAV systems. This is actually a VAV system. This is a big open office area here. And the architect wanted the ducting to all look like it was one piece. And so there's actually multiple zones, but it looks like ducting. There's actually a blank off panel here. But what you're seeing is you're seeing the perimeter zone. Is it in heating or cooling? It's in heating. This is the core zone. Is it in heating or cooling? It's in cooling. So this is a situation in an open office where we have simultaneous heating and cooling. Now, a VAV system, this is working correctly. That's a VAV system is designed around perimeter and core zones. So there's nothing wrong with this picture. At the code level, I've been involved with code development. We've been trying to figure out how to minimize this. In fact, in the new Seattle Energy Code, Washington State Energy Code, we're trying to implement deadband in zones that freely communicate with each other. These are two temperature zones, perimeter and core. And so we thought we'd be smart and wrote language into the code that said, well, if you're building a new building, we don't want this, or we want to minimize this. And so if it's a new building, we don't want you to energize heating in the perimeter zone until it's 5 degrees warmer than the core. And in the core, we don't want you to implement cooling until it's 5 degrees warmer than the perimeter. So has anybody tried that, by the way? Implementing a deadband within zones that communicate with each other? I did, actually, down at Seattle. And we haven't seen the results yet. Yeah, so the reason I'm curious is that generally people want to have the same temperature throughout their space. They don't like going from hot spaces to cold spaces or that type of thing. So I'm just curious, that's in the code language now. Because we were looking at VAV buildings for energy performance, and they weren't performing very well. All that South Lake Union, Amazon, VAV stuff is not our better performing buildings. And this is one of the things, in fact, if anybody is knowledgeable of the code, there's now a high efficiency VAV option because we were trying to address the inefficiency of VAV. No. I doubt that. It was a slow response. Yeah. No, we're just trying to figure out if we can make VAV more efficient. We'll know more in the next code cycle. So anyway, but if you obviously see situations where there's simultaneous heating and cooling, we want you to review that sequences for unintended issues where you've got adjacent zones with one zone set at 68 and this is set at 75 and they're fighting each other. That would be an area of maybe making some recommendations, taking an average temperature, increasing the deadband between the two, resetting the 68 up and the 75 down, something like that. For any unintended or inappropriate simultaneous heating and cooling. So this is an example that PNNL provided of Essentially the zone temperature up there, the heating valve is opening, and zone occupancy schedule, there is no zone occupancy schedule. So essentially the reheat valve percentage and zone temperature, it's just sitting there temperature heating. There's no schedule in there. The reheat valve is active all the time during unoccupied and night periods. So looking at, we don't want VAV boxes heating zones at 12 o'clock at midnight or during unoccupied periods. So we can look for those VAV boxes that we're going to do functional testing. We can look at valve position, status, zone temperatures. We can trend that and verify that they're being set back. Air balance issues. One of the requirements is that you note any indications of significant air balance. This is a voluntary thing. We're not requiring you to hire a balancing contractor to go in there and do an air balance. But if there's obvious stuff, you can't get you open the door and it's a wind tunnel coming through, or obvious overpressurization or underpressurization, then we want that noted in the report. That would be something for the owner to follow up, whether that's inadequate makeup air for process exhaust, whether that's overpressurization during economizer mode. So they've overridden their economizer because there's howling, the doors are being forced open from overpressurization, which is a symptom of inadequate relief. So maybe we need to take a look at the relief air system. But what those, or imbalance in the building itself, too much air here, not enough air over here, people complaining about inadequate airflow. Just a recommendation. So if it's not, they don't have to do anything about it. It's a voluntary requirement, but you could recommend some rebalancing or doing an air balance or basically a comfort balance. Excessive ventilation rates, and I already talked about that. Here's some trend logs of, and it's kind of hard to see here, but this green line and this blue line, this is mixed air temperature and outside air temperature. So if your mixed air temperature tracks outside air temperature, what's your percentage of outside air? 100%, a lot, right? I typically wouldn't see that unless it was a 100% makeup air system or a DOAS system, something like that. So this is obviously, and well, wait a minute here, we should be bringing in 100% outside or even high ventilation rates. Here's another outside air damper open during unoccupied hours. So here's the outdoor air temperature. Here's the outside air damper position. It doesn't go below 15%. So it's not closing at night. And if the outside air damper is open and not closing, might as well leave the window open. That's a pathway from your return air through the unit to the outside. So that's a window left open. Multi-zone systems, it's a voluntary thing, but identify any zones that are dominating multi-zone. We talked about this, I call it a rogue zone. So, the computer room that's demanding 55-degree air, the VAV box is 100% open, 24/7, never closes down, which is not allowing your main air handling unit to reset above 55, because I've got this constant cooling demand. A recommendation, hey, maybe we should replace the VAV box, need more air here, so it'll throttle, or provide a separate system. We need a ductless mini split in there so that we can implement a reset schedule. There's an awful lot of systems out there that have the capability of reset but aren't doing it for a variety of reasons. We tried to address that in the code to try to get engineers to design their cooling loads instead of 55-degree air, 60-degree air, so we could still meet those loads at 60-degree air. Dispatch center in an office building, so they've got one floor that's 24/7. They're having to run their full chilled water plant, hot water plant, 24/7 just for this one floor or one zone. And I know that happens out there, and we have those instances, whether it's a data center on the floor or some tenant. But that's an opportunity if we can serve that with a separate system and shut that down. And then the last thing on the HVAC side is just general maintenance, cleaning, and repair. This is your judgment is, boy, you've got some general maintenance. Before you can tune up, we need to get the filters changed. We need to get some duct leaks. I feel there's duct leakage, there's rotted flexible joints that need to be replaced. The coils are dirty. The outdoor condensing unit is full of leaves. It's just some general cleaning stuff. Missing or damaged access panels or door seals. Spacer bars missing from the filter rack. Those types of things. Missing or damaged mechanical items. Damaged duct or pipe insulation. So somebody had to remove some pipe insulation to do some work, never re-insulated the pipe. HVAC dampers that are frozen. Equipment at the end of its service life. And that's just suddenly saying, hey, getting the owner to think about, I've got some capital improvements I need to think about here. So, you know, just some general recommendations on cleaning and replacing damaged equipment, voluntary recommendations. So jammed or frozen dampers, wired poorly, disconnected dampers. How many have seen disconnected dampers? Loose wiring connections.
Well, if they're fired open with baling wire, does that mean they're disconnected?
Yeah, I'm sure we've all seen everything. So I think this is a good time to take a break. So let's go ahead and take a 15-minute break, then we'll come back and wrap this up. On here, I did want to make, when I mentioned lastly here, maintenance and repair, they are required to replace dirty filters. That's not optional. That's a low cost, no cost improvement. What's optional is that if the equipment is at the end of its service life, it should be replaced, then you should make that recommendation, but they don't have to do that. That's not part of the scope in the tune-up project. If there's stuck dampers that are critical to the situation, you know, those need to be fixed. That's part of the deficiencies. But replacing the equipment is not a requirement. It's voluntary. But dirty filters, that type of thing, need to be replaced as part of the tune-up assessment. So we talked about HVAC. So on the lighting side, the lighting requirements for the tune-up are fairly minimal. There's interior lighting system and controls, exterior lighting system and controls. You can go to the tune-up assessment, the inspector rules. So spot check lighting levels. That's all we're asking you to do. It's an office building, spot check some lighting levels. Does it make sense for an office building? Is it 30-foot candles or is it 100-foot candles? Does that make sense? And there's some guidelines on that. And it's voluntary. You can recommend areas where the lighting could be reduced. You notice that it's excessive lighting. They don't have, that's a voluntary requirement. But there's an opportunity there. So that may be, now you're maybe looking at Tune-Up Plus, maybe a lighting project that's part of that. But we do want you to just spot check and see if the lighting levels are appropriate for the use. If there's occupancy sensors or any kind of lighting controls, verify that they're working correctly. Do they turn the lights off on that? So that's one area. So you could use a light occupancy logger. You could turn the lights off and wait, hit the timer, see if they come on automatically, or just basically observe when you walk into the bathroom, the lights go on. How long does it take for the lights to go off? And then on the exterior, you can verify that the lighting controls are working correctly. How would you verify that the controls are working correctly for exterior lighting? They're off during the day and they're on at night. Pretty simple. So obviously if you're doing your walk down and the outdoor lights are on, that's it. Well, I got to figure out, is it a photocell? Is it a time clock? Is it a photocell that's working correctly? Is it a time clock that's not programmed? That's a deficiency that needs to be fixed. That's a low cost, no cost efficiency. I mentioned in our library we have these light occupancy loggers, and they're really unique in that they basically give you when it compares occupancy to the lights being on. So we can see here that the lights being on track occupancy. That's what we want to see. If the lights stayed on the whole time, even though the occupancy varied, then we'd have a problem. Our OCC sensor isn't working correctly. And so there's ways that we can verify and we can log on whether or not. And obviously in a building, in a large building, you may have 100 occupancy sensors, 500 occupancy sensors. Sampling's okay. Look at how many, spot check those, and see if they're working correctly. Lighting control schedules. If you have a building that has a master control panel, is the date and time correct in the panel? Does the lighting schedule match occupancy? Is our holidays program into that, or when the building is not occupied? What's the length of the override? You know, if the override's 24 hours, 2 hours, what's appropriate? Are all the lights controlled? So if they do have central lighting control panels, again, it's just your best judgment. Is there an opportunity, low cost, no cost, through programming changes or scheduling that can reduce energy use? On a voluntary on the maintenance side is obviously if you notice there's a whole bunch of incandescent fixtures and T12 lamps. There's an opportunity there, or magnetic ballasts, or fixtures that have burned out lamps. And so, you know, it's a voluntary measure, but it's something that you can note as an opportunity for them. Replace with LED, put in occupancy sensors. Those are all opportunities. Not required, but a potential opportunity for the owner to pursue. So that's it on lighting. So it should be fairly, you're going to, for the asset score, you need to know approximate number of fixtures and type. You know, I wouldn't spend the time counting every fixture in the building. I may look at a room, figure out the number of fixtures, divide that by the square footage. So now I have a fixtures per square foot or square foot per fixture, and just use that for the building. That's going to give me my number of fixtures. Okay, so you don't have to, we're not doing an investment grade model here. We're doing an estimate through this asset score. So get your general fixture type, make an estimate of the number of fixtures for the building. And the predominant fixture. I know some of these buildings, I know when I was working with Amazon and Seattle City Light down there, you know, they had 50 fixture types. Lynn remembers those buildings. So for your model, just go, the predominant fixture is a 3-tube T8 with electronic ballast. This many per square foot, here's how many in the building, and call it good. Hot water, domestic hot water side. So most of their buildings are gonna have domestic hot water systems, if not just for the, for lavatories, janitor closets, that type of thing. Processed water, so restaurants, and there's some exclusions for those types of things, they're outside the scope of this. So we're primarily talking about service water, not processed water. So there's a couple of things to emphasize. One is hot water temperature. Is it appropriate? You know, if it's a public lav, is it 115 degrees, or is there a mixing valve? Is the mixing valve temperature appropriate? Use your judgment on that. If there's circulation pumps, does it have control? You know, is it plugged into the wall? There's no control there, but there's maybe an opportunity. We're not requiring that you install a control, but you know, there's plug-in timers that you could plug in here and turn that pump off at night. So relatively low cost measure. Is it controlled by the BAS? And if it is, does the schedule match occupancy? A lot of the newer buildings now, under the new codes, require that the pumps be controlled by not only schedule, but demand. So if there's an aquastat, does the set point of the aquastat make sense? So it shuts the pump off. You know, a lot of the circulation pumps now have integral control, so they've got a timer built right into the circulation pump. Is the timer set at the right time, right day of the week? Is it even set at all? If you run across maybe a time clock or a mechanical time clock, are the settings correct? Or all the pegs missing and off laying in the bottom of the box? Right? I'm sure a lot of you seen that before. So pretty straightforward. Temperature and circulation control on the domestic hot water side. You know, there's if you notice missing pipe insulation or whatever, you can note that in your report that there's a bunch of missing pipe. It should be insulated. You can use a thermal imaging camera and pretty easily determine whether that's hot water piping, cold water piping, recirculated water piping. You'd want to note that. That's a relatively low cost thing. It's not required, but insulating the piping does reduce energy use. So that's on the hot water side. On the water usage side, there's kind of 3 areas to look at. Cooling towers. So on water-cooled systems or hydronic heat pumps, you may have a cooling tower, irrigation, and fixtures themselves. On the cooling tower side, I'm going to get my slide because I wrote some notes here. The only function that you have that's a required function or a required measure is to calibrate and control the blowdown. So in the sump here, pretty much most cooling towers use conductivity to determine when to remove water from the sump to add fresh water to dilute the mineral concentration in the sump. And that conductivity uses a sensor, conductivity sensor. And so is it calibrated? So conductivity meters, I have one here in the library. They're around $200. A logging conductivity meter's a little bit more expensive. I don't have one of those, but I have a static measurement. So we can measure that, look at what the conductivity's reading, and then calibrate if required. So that's required for cooling towers. The other area that you can note is leaky blowdown valves. Valves that remove water from the tower even though they're closed are still leaking. That's fairly common. And in fact, we're going to have here at the Smart Building Center, we're sponsoring a cooling tower workshop with Seattle Public Utilities on March 21st. I'm going to try to get a blog posted. I thought a blog had already been posted, but it hadn't been posted yet, from 10:30 to 1:30 on March 21st. Cascadia, Roger Van Gelder, some of you may know Roger. They're going to be here to do a cooling tower workshop for efficiency, kind of around I don't know if anybody's seen the Cool Tunes guide that was put out by Seattle Public Utilities on efficient cooling tower operations. So addressing makeup water issues, concentration cycles, controllers, that type of thing. So this is a system that can, and then, those are the required things: calibrate water treatment, leaky blowdown valves, replacement. And you can determine leaky blowdown valves is if you've got water consumption, if your makeup water meter is running when the tower's off or not in demand, you're losing water out of your sump, like overnight, for example. And we can measure that. And then if there's any other kind of repairs, those are voluntary. So whether it's fans, bearings, leaky sump, whatever those other repairs may be, those are voluntary repairs. Or maybe an end of life, the cooling tower is on its last leg and it needs to be replaced. That would be a voluntary recommendation. And just the focus here to keep in mind is that we don't want to waste water in this. And so when we do the cooling tower workshop, you'll learn more about this, but it's all about cycles of concentration. What is the ratio of my sump water to potable water, my makeup water? And we want to run fairly high. We have soft water in Seattle, so the higher the concentration ratio, the less water we use. And so we just want to make sure that the concentration ratio is appropriate for the situation, that we're not wasting water in there. And so that's the point of looking at conductivity, looking at the controller, verifying that we're not wasting water through the system. Also on irrigation, if you have, and what's the square footage minimum on? 500 square feet. So if you have more than 500 square feet of irrigated area, then we want you to, and there's automatic irrigation, and there's some sort of rain sensor or device. We want you to make sure that the rain sensor device is working correctly, that we're not watering when it's raining outside. And so a lot of those devices, essentially, this cap rotates basically fills up with water, and if it's filled up to either 1 inch, 1.5, quarter inch, 1/8 inch, you can set it. It will skip that next cycle. And so it's fairly easy to locate the rain sensor, override the irrigation zone, activate the sensor, See if it turns on, or it prevents that zone from operating. You can test continuity, you can adjust, calibrate, and replace that sensor. So that may be a recommendation to replace that sensor. Again, greater than 500 square feet. And then irrigation schedule. I'm not a landscape maintenance person, so I'm not the one to tell you how much water it needs. But you know, if there's something obvious that they're irrigating for 12 hours on, 12 hours off, then there's something that maybe that's something that they can pursue on their irrigation. And there's smart irrigation systems now that use the internet and tie into weather reports and look at what the rain forecast and what it did and adjust the rain schedule accordingly. Water features, if there is a water feature, is it shut down at night or unoccupied where appropriate? So are they running their water feature pump 24/7, or is there an opportunity to shut that down at night when they don't need to be pumping water around? And then maintenance, cleaning, and repair, obviously on irrigation systems, if you've got broken heads and they're just burgling water and you're watering the sidewalks, those are, you know, adjust and repairs appropriate. Obviously in the wintertime, you know, around here, Mother Nature irrigates for about 9 months of the year. And so this is something that you would observe over the summer months if they do have a significant irrigation system where those opportunities are. Recommend repair of scope more than routine maintenance. And so if it's a matter of, boy, you really need to dig up all this piping and redo your system and go to drip irrigation and do all that, that's a voluntary measure. That's a major capital investment. Where if it's just fixing some heads, then that's something that during your walk down of the building around the outside, you notice broken heads or areas that are being irrigated that shouldn't be irrigated, then they're required to fix that. On the fixture side, there's no requirement that they replace all their fixtures with low flow fixtures. It's all voluntary, but if you do notice that, you know, they're hands-free, you go into the restroom during your walk down and the hands-free faucet comes on and never shuts off, or the water closets are double flushing, or something you just do a quick GPM. I'm sure some of you probably use these bags before. You notice that the lab faucets are flowing 2 GPM and there's water everywhere. Then those are some simple recommendations where they can change aerators. They can adjust the automatic flush valves, the delay on the flush valves. Fairly simple water efficiencies. These are voluntary, but use your judgment. If you see waste, if you see water waste, note it. Put it into your report. So any questions on the water side? Pretty straightforward. So irrigation is required. So, you know, even this time, you know, most irrigation systems are winterized. So you're not testing the irrigation system today because it's been all blown out. It was compressed air. They blew it out. They winterized it. So the only way you're going to test that is in the summer during the irrigation season. And then the final walk down requirement is on the envelope. So well, highly recommend that you walk the outside of the building and just, you know, just looking at exterior conditions. You know, if we were to go outside right now and walk the outside of the building, there's some interesting things we'd see. We'd see that this building is old. Brick construction with, not on this orientation, but if you look at the other orientation, wood frame single pane windows, double hung, very leaky. We'd see some utility. So, you know, what are the exterior conditions of the windows? Are the windows operable or are they fixed? Are they single pane, double pane, or triple pane? I don't have the instrument with me, but I do have an instrument that you literally put it up next to a window, hit the button, it goes through and it will tell you the thickness of the glass, the thickness of the airspace, if there's a low E coating and what surface the low E coating's on. So if you're unfamiliar with the actual what kind of glass is in there, is it low E, whatever, then there's an instrument that you can use to measure that. Are there any windows, outside doors open during the walk down? So, you know, if you see doors open, what's that a symptom of? If you saw doors open or windows open on a day like today, too hot somewhere or inadequate ventilation. So we're just looking for unsealed weather stripping that's missing, just the real obvious stuff as you walk around the building. Elevator shaft dampers, and so essentially they're open, and we've got a chimney inside the building. A lot of stack effect, whatever that's called. Recommend repairs to scope work is more than standard maintenance. Any significant duct leakage, big hole in the duct. You look above the ceiling and the duct is disconnected from the diffuser. I'm sure we've all probably seen that at least once in our walkthroughs. We need to reconnect that duct. Insulation that's falling down, gaps under, so some general requirements on the envelope. So any questions? So went through the requirements there. You can use so there's about 23 assessment elements, and I highly suggest that a really good checklist for you to use is to print out that reporting tool, that Excel spreadsheet, because that's going to give you the assessment elements, and those boxes where in the field you can document however you want to document your findings, but those are the assessment elements. Sampling is okay. So on your larger 12%, no fewer than 10, and larger buildings, no fewer than 20. So take a look at that. So when you're developing your scope, you can then develop, how much equipment, what do I need to functionally test on that? The lighting, the hot water, the building envelope are pretty small in scope. Domestic hot water, go find out what the tank is, the type. Is it a circulation system? Does it have a time clock? How is it controlled? And then temperature settings, is it appropriate? If there's a restaurant that's 140-degree water, we don't want to worry about that. We're looking at basically service water for the building. So